Welcome back, ladies and gentlemen, to Murph Codes Front-End Web Development, where we are learning HTML, CSS, and JavaScript. Not gonna lie to you folks, I am a bit sleepy today. I don't know why. I slept pretty good last night, but the past half hour here, while I've been waiting to get started, I have been feeling my energy just leave my body. So, I don't know how much we're going to get through today, and we have a lot to get through before I even get to the main topic of what I wanted to discuss today. So, we're going to try to power through this. Bear with me. As you can see from our editor, we have a second page that we have started. Random.html. It's this one right here. Kind of feel like my background music's a little loud today. That's a little better. Of course, now it's probably too quiet to even hear. I don't know. Maybe. Anyway. I have made some changes to the website since last we played around. I've got it here on the mobile view, as you can see. Narrow, so we've got the hamburger menu. When we click on that, it expands the header. Well, hello there. Welcome to the chat, Nable26. Or Nabe26. We're just getting started, so you're just in time. Anyway, we click the hamburger menu. Our header expands to show our navigation menu. Otherwise, we have in-page navigation to take us to our table, which is still loading from Ajax, by the way. That still loads that, oh, what do we got here? Oh, that's just a couple of sound effects not loading properly. I'm not worried about that right now. Our in-page navigation can also take us to our soundboard. So that's all still working, even though we've got a few errors here from from some stuff failing to load. I don't know what that's all about. It wasn't doing that last time, as you all saw, so who knows. I did make a couple of minor changes. I took our sound object out of our script. Where normally, yeah, that's where we would put our... The sound effects might be a little loud, yeah. I haven't properly adjusted the volume for that. No, that's still cranked. Let's drag that down. Anyway, I took the sound object declaration out, moved it to its own little thing. So all of our sound stuff is now handled by the soundboard.js file. I felt like that was a better spot for our sound object, which we discussed that last time or the time before? Last time, I think it was. We're basically just making an object that adds a little new functionality to the audio object. Oh yeah, you can decrease the volume of everything. I have Chrome running through my display, through speakers. I have the output of my speakers as an item in my OBS, so now much more reasonable. Some of these are still a little loud. Not as loud as it was before, though. But yeah, so I've got the sound object, which just adds streams to the audio object. The audio object is already an object in JavaScript. It's the JavaScript model of the audio tag in HTML. You can use it to like set volume and all that fun stuff. We take those same parameters, but we also add streams. So essentially, it's an array of the same sound effect. But if one is busy and we go to play it again, instead of waiting for it to finish playing, we can just play the next one on the list. So that's how we're able to get multiples of those sound effects. That'll come in handy when we're doing things like laser blasts and sword swipes and stuff like that, you know. Because you're not always going to want to wait for the sound effect to finish before playing that sound effect again. So we've got that set up. We moved all that into the soundboard.js file. There is a new file here, which we did not talk about last time. This is the user controls.js. I also broke my my own styles as far as naming conventions. That's what I'm looking for. Conventions for file naming. I went with the camel case instead of underscoring for spacing. Don't worry too much about that. Again, if you were doing this in a professional setting, you would probably want to follow whatever the conventions are that your team uses for your file names, stuff like that. We're looking at this from I just want to make my own crap point of view. So this is not, you're going to learn this stuff and you're going to go on to work at Google. No. All right. If that's your ambition, this might get you started, but you got a long road ahead of you. I'm not going to fool you on that. But anyway, this file, the user controls.js, this handles all of our keyboard commands as well as our mouse commands. Now, for the keyboard, I've declared a function here, player control key, takes the event as an argument. And using that event, we just run a switch, which is a conditional, like an if statement. Except you can have multiple and you don't have to write various conditional checks for it. It just does the one conditional check, and then you write the various cases. So, what we're doing here is, what are we doing? We are checking the value of that event's key. Because the event we're going to be feeding into this function. If we come down here, we're adding to the body of our document an event listener for key down. A key down event. Anytime there's a key down event on this document, it's going to call the player control key function, and it's going to pass the event object to our function. We're going to assign the event object to key event. We're going to check key event's key property to find out which key was pressed, because it's a key down event. It's listening for a key down event. So it wouldn't be much good if the key down event didn't tell you what key was down, would it? No, of course not. And for each key that we want to listen for, we just make a case for it. Case W, case A, case S, case D. That's our WASD Minecraft sort of up, down, left, right. If you're familiar with PC games, that ought to be familiar to you. I've added a few other keys we're going to listen for. Q in order to quit. E in order to look into an inventory. R in case we want to have some kind of dialogue going on. We might not actually end up using that one for our own game making purposes, but like if you had like an in-game chat, that'd be a good one. F, using some item in the action bar. Your action bar consisting of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. We even have a case for space if they hit the space bar. And then if somehow we get a key down event that we haven't handled a key press for, because there's a lot of keys, we don't want to handle every single key press because we're not going to have that many different actions in our very simple browser game. We just include a default break. Doesn't do anything. So, switch, this is new. This is something we have not talked about before, but it is, like I said, like your if statement. You have the switch keyword. This is the condition you're going to test for. These are the values that you're going to be looking for this to have. If there is no match, you're going to have a default at the very end. And for each match that you do want to have handled, you're going to write case, the value you're looking for, colon, and then you're going to have some JavaScript lines, some lines of code. Currently, we are just feeding all of this out to the console, so you'll see that popping up here when we get around to testing this out. After you've handled the key press, all the things you want it to do. Be sure to throw in a break at the end with a semicolon. If you neglect to put this in, it will go on to the next case, as though this is also true. So if I took this break out of here, every time we press the W key, our console will tell us that our character should be walking north, but since there's no break to take us out of the switch, it would also tell us that it's walking west as well. Now, sometimes you want that fall-through behavior on your Switch conditionals. Sometimes, not always. In this particular case, we definitely don't want that fall-through behavior. But it is something to keep in mind that you can exploit for your own purposes. So if you're checking for a value, say somebody filled out a form, and they put in, they're the head of household. And they have, 10 kids. Or no kids. Or whatever. Well, putting in that they're single, they may still have kids. So if your switch case was, household status, and then somewhere in the, the casework, you'd have, head of household print, oh, you're the head of household. And then the next one, you'd just have a general response that handled, oh, we see you have this many kids, blah, 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 these all your dependents. Like, you'd still have that second case go, but not the first one unless they actually indicated that first part, but it would just fall through. So, sometimes you want that. Sometimes you would want to run multiple cases for a thing, just stack them in the order that you would want them to progress through. Take the breaks out if you want it to have that fall-through behavior. If you don't want that fall-through behavior, if you want it to kick out as soon as it's done with whatever's in this case, be sure to put your break in there. Don't forget it. And default, if you're pretty sure you're going to be feeding your Switch any values that you haven't written a case for, and in our particular instance, yes, because we're going to feed this Switch statement literally every key press. Every key press. So if they hit backspace, if they hit F6, if they hit the Alt key on the left or right, it's going to trigger this. And we want to be able to handle it every time. Doesn't matter if we actually have an action tied to the key or not. We want to handle it. And so we have that default. Mouse clicks are pretty easy to deal with, though they do sometimes give me trouble because I often forget that in order to do mouse dragging, which is, you click the mouse button, and while you hold the mouse button down, you slide the mouse. You're probably not going to be able to do single and double click at the same time. It gets a little weird. Like, it doesn't always work. So, instead of tying your click to the just the regular click event, we tie that to the mouse down event as well as the click event, because it can sometimes be a little sketchy as to which one it's going to do. But then, in our mouse drag function, which happens on a mouse down, event, which is just the mouse button has gone down. They've pressed the button. We're calling this mouse drag function. Now this mouse drag function also takes the event, assigns it to the thing, and what we're going to do is we're going to check for the offset of the mouse position. Offset X, offset Y. That gives us on a Cartesian plane where our mouse is. Not a perfect Cartesian plane, mind you. This is a programming Cartesian plane where the top left is 0, 0. And as you go down on your y-axis, the value increases, and as you go to the right, the x value increases. So if we just did a click, just a plain old click event, this is what it would do. It would tell us where the mouse is clicked at. On the mouse down event, which triggers our mouse drag event, it does the same thing, but we're also going to enable the event for on mouse move. And then we also have a MS drop, which is going to disable the on mouse move by setting that value to null. So, mouse goes down, we turn on mouse move. Mouse button goes up, we turn off. Why is there so many spaces there? We turn off the on mouse move event. What does the on mouse move event do? Well, it takes that event argument, and every time the mouse has been detected to move, we're gonna print to the console that we're dragging to the coordinates of wherever the mouse has been last detected. And what does this accomplish? Well, this accomplishes the perfect drag and drop detection. Because how do you drag? You press down the mouse, you move the mouse, and then you release the mouse button. So, mouse down event, mouse move, mouse up. So, drag, drop. I know. Very convoluted. But this is the best way to handle being able to include dragging something in your game, in your browser JavaScript games. If you have no need to detect for dragging, if you're just making like a point and click adventure, but you're not having them drag things, you can do away with all of that and just go with, the click and double click event listeners. And that should be absolutely fine. Why do I have that as... Yeah, no, that's wrong. This should be mouse double. I don't know if it'll work, but I have it there. But, like I said, our single click event, we made that part of our mouse down rather than making it its own thing. But that's because, as you're about to see, single clicking has a hard time being detected when you are also handling for a mouse down in order to enable that drag and drop. It's a thing. It's a thing. I feel like it handles better in Firefox than in Chrome, but that just might be, you know, my own experience. Might not even be, like, legitimate. But anyway. This is our app. Oh, I should show you. That random HTML is what we're using for the app. I tied the user controls in at the bottom. And also where we would normally find our main, I'm using a different JavaScript app because we don't have anything in main, so it's not like we would have to really worry about it, but in our index file, our very first welcome page is where we're using main. If we wanted to do something with this very first page, we would edit the main. Since we're just focusing on the app, we're going to keep all that here in the app file. And don't worry about this stuff right now. We'll get to that in a brief moment. I just want to show you how this user control stuff works real quick. And then we're going to talk about this. But anyway, I have that tied in place of main. That apps.js. I didn't have to, but I wanted to, in case we decided to go back and use main for something else. Since we do have 2 pages here now. And that second page is strictly the app. Since that's strictly the app, I felt naming it app.js for all the script that's going to handle the action on that page made a little more sense. If it doesn't make sense to you, don't worry about it. Do what makes sense to you. Alright, so here we have the console. Here we have our app. As you can see, single click event happened. And it gets outputted here. It tells us the X and Y is, the X was at 213, the Y was at 154. See, I'm not getting a double click event. It's just handling the single clicks. Which is fine. Let's say I press down, drag, and release. You can see I have a whole bunch of dragging, and it gives us the coordinates for each one of those. We can use those values in our code. So we can do things like aim our attacks, or interact with objects within our game by doing things like detecting how far away from an object our mouse click was. If our mouse click is within the boundaries of an object's, hit radius, do something with that object. This will be the basis for the game we're going to make. Still don't know what we're going to make, but this is the basis for that game. Now, I said we also handled key presses. If we press W, a little hard to see there through my avatar. My head makes a better door than a window. It says walking north, A, walking west, D, walking east, S, walking south. It's our up, left, right, down, Press the space bar. Initiating context-sensitive action. Hit Q. Quit menu. Hit E. Displaying player inventory. I mean, obviously, it's not really doing any of these things. It's just outputting that text to the console right now. But where we have the line where it tells the console to display these texts, we could input functions for these actions. Or whatever other actions we would like to have. And we can also expand this to handle far more key presses than what we have here. This was basically just set up to mimic, like, you know, the very classic Minecraft controls, you know, that kind of thing. I mean, Minecraft isn't the only game that handles that way, nor was it the first, or will it ever be the last. But all of our key presses all handle basically the same way. It's pretty easy to deal with. It's really all it is. Now, in our user controls file, this doesn't have to be its own separate file. We could have dumped all of this into the script and lessened the number of files we need to work with. But I like putting things into individual files where it makes sense. Like the stuff that handles our sound, that's all in one file. The stuff that handles our controls, our player input, that's all in another file. This is kind of a division of labor sort of thing, where I don't have to worry that I'm going to accidentally start doing something with a function that handles player input, trying to fix something that's an issue with the sound. Okay? They're two separate files. They're not connected. They're just their own individual thing. And I feel like that's an appropriate way to handle some of this stuff. Now, you'll probably see some, you know, make a JavaScript game tutorials on like YouTube and whatnot, where they just put everything in a single file. They might even just put it all in the in between some script tags in the header of their index file, and the whole thing is literally just one solid file right in the HTML. And that's fine if that's how you want to do it, because it makes the most sense to you to just keep it all contained to one file instead of like what I've got it split up here. If it works for you, it works for you. Because the disadvantage here is I have to remember to add in a tag for every page that I want user controls on. If I don't do that, the page doesn't have user controls. And I also have to remember to add in the soundboard, otherwise there will be no sound. This page has no sound. Now it has sound, but it's probably also going to give us an error because we do not have a board. We don't have a soundboard object in our document. But we'll still be able to use this sound object in our code. It's just this part here where it's looking for those buttons that are in our original page, because it's going to look for this HTML creation in order to assign it these sounds. But since this doesn't exist in this page, we should get some kind of error. Yep. See, it's looking to add an event listener. But it would like to add it to that sound object, that soundboard div. We don't have that. There is no soundboard div. Now what we can do is we can take this part. Yeah. There we go. There we go. Let's take that out of there. This we can put in main. Alright, now that should still work. This is still being a pain in the butt. And I know why it's being a pain in the butt, too. I know exactly why it's being a pain in the butt. Yeah. I don't care about AdBlock Plus. I need to view the page source. Chrome. Alright, so we go into here, style, reload. Now it's updated our style page. Go to my app, hit reload. There we go. Now I can hit the page source here. Reload. Reload. I don't think I need to reload that for any reason, but just in case. Yeah. I don't know why Chrome does this so often, but it just decides it doesn't need to reload the files that I'm trying to test. I probably have a catch setting or something that I can fix. Yeah, no, that part's not in there anymore. Would probably help if I saved the file, though. Is there a way to refresh it? I mean, there probably is. I'm just... Soundboard. Now hit refresh. All that extra garbage went away. We just have our sound object declaration, which is all we need. Go into here, hit refresh. Boom. No more error. We go into this page, hit refresh. Why is it not making the cat noises? Which one isn't working? I bet it's this one. Aha. There we go. Still not working. Why isn't it working? This is the struggle I have with Chrome. I don't seem to have this problem when I'm doing things in Firefox. Here we go. Sound is not defined. Do I have them in the wrong order? I do. Okay, because Soundboard only has our sound object declaration now, let's move that to the header, because that doesn't need to be down at the bottom anymore. All right. Our soundboard works again. Why is it at what's the args? Why is the args? Ah, okay. Do we not have an args being defined? No, we have an args being defined. Oh, I know why. It's because I put it above. Yeah, no, we gotta put that below. Order apparently really matters. So if you were wondering, order matters. What were we even using args for? I don't know. I think we were using that for our debugging stuff, but what we can do now is, you know, we have this constant sound on equals true. What we could actually do because we can check for args. Sound on equals args 0. Now, this becomes a flag for determining if we have sound effects or not. We could tie the value change here to a mute key, if we wanted. You know what? Let's do that. Alright, so basically what we're doing here is we are setting it up so that if we hit the M key, we're going to flip that arg's value from true to false. If it's already false, we're going to flip it to true. Alright, we have it declared here. Where did we declare that? We declared that here. That's the very first page. Very first script. Okay, this should do some kind of interesting stuff. As you can see, there is no sound. However, we didn't add user controls to this page, did we? I mean, why would we? So let's add some user controls to this page. What do we got here? Are you telling me the document has no body? Is that what we're going for here? Did I fail to do my... No, I failed to do the thing correctly. I didn't, okay. I don't know if that's the problem, but it is a problem. Because I forgot to put a break here. Still don't get what the problem is here, because Yeah, I don't know. So what we're going to do is we're going to take these out of here. We'll put them in here after our event listener. Hopefully. That'll make some sense. So now all our user control is doing is defining the controls, but we're leaving it up to our app document to set those controls here in its function. And then in our index, what we're going to do is here we have on load. We want on key down, because that's the only one we're really concerned with on this page. And we want this one. Now we might have some trouble with this. Hopefully not. We'll see. So, what we've done, and honestly I should keep a copy of that in here, but document or comment this out instead of getting rid of it entirely, because if we try to use this module in another page, we're going to want to know how to attach those. And we know this works. How do we know this works? Because it's working here. All right. We have no sound. We press the M key. True is not defined. Oh, that's because I'm in JavaScript, you knucklehead. Capitalization matters in your binary. Press M. We still have no sound. Why do we have no sound? Okay. Page source. Oh, I know what we're doing. We're failing to actually do this properly. That's what we're doing. So what we should do is we should comment this out. We should make this just read directly from args. And we can comment this one out. There we go. We're getting no sound. We press M. Sound. Press M. Sound off. Sound is deactivated. We have effectively tied our mute key function. Hooray! That's how we do that. Now, big round of applause. We all take our bows and curtain. Except we're not done yet. We broke the functionality of our app. Somehow, we broke the functionality for our app. Okay, so why does that not work? Oh, that's right. No, that's right. User controls. Well, that's annoying. What is that? Player control key? Player control key. Here. Maybe we're just going to be better off putting everything on this head tag. I mean, it's not what I would have preferred, but if that's the way it's going to force us to do it, that's the way we're going to end up doing it. Who knows? This might even resolve that issue we have with single click and double click not working when we declare on mouse down. Who knows? That just might be a better way to handle this. We'll see. So we have on mouse down to start the drag. We have double click, single click, and control, or the key control. Let's see what happens. Okay. Our key presses seem to be doing something. Single click does something. Dragging does something. However, we're running into a bit of an issue here. We can't disable dragging. Once we start it, it doesn't want to stop. So I think what we're going to want to do to that. Those still work. But our mousey mouse does not work. And that is still a problem. So we're going to take that out. Take that out. Maybe if we add it to window. Because we had to add the resize to window, which, you know, that actually makes sense because that's a thing we're doing on the window. And that seems to work. We got some changes there. Reload that. Single click. We still don't have double click, but we can do drag, and when we release it, it stops dragging. Which is better than what it was doing. We still can't do single click and double click as well as our drag and drop at the same time, though. I've got to find a workaround for that, and I will at some point. But dragging works. Key controls work. Muting our sound works. And it still works over here. Unfortunately, it doesn't mute anything while it's still in play. So, if a sound effect is triggered and then we hit mute, we just gotta let it play out before it'll deactivate and not play anymore. But that's okay. That's a minor discrepancy we don't really have to worry about. So, things are working. Now, if you're scratching your head as to like, okay, when do I attach the event listener to the document body versus when do I attach it to the window? Your guess is as good as mine. I don't know. There's probably an answer to that. And I'm sure if I bothered to look it up, like, we would find a solution. Probably without even a whole lot of looking. But am I going to look that up right now? No. I'm tired. We haven't even gotten to the meat and potatoes of what this episode is supposed to be about yet. And we started exhausted. So, sorry, I don't have, I don't have my usual energy level today. I'm not even sure why that is. I slept pretty good last night. I've downed nearly a full can of Monster. And not so long ago that I ought to be crashing already. We're starting to get some interactivity, though, with our user controls. We have sound. We have this tab here, which is just a big blank black box, which I haven't even talked about yet, and I should do that. I should tell you what you're looking at here, because what you're looking at here is not just a big black box. Because if you see me resize the window here, as you can see, there's some blue underneath there. This same blue. Why is that? Well, that's because underneath the black is the actual body of our document. The black is a canvas element that I am having redrawn to the size of the window every time the window is resized. So let's take a look at the apps.js script that I've got here. I have a constant FPS of 30. That's frames per second. We can tinker with that number later, but I find for browser games, 30 is a good number. I mean, it's a browser game. You can't expect, 160 frames, in a browser game. You're crazy. That's ridiculous. I mean, maybe if your PC is souped up, like, beyond all common sense, Chrome will do that, but Chrome likes to take whatever RAM is available and just hoard all of it. So, good luck. You might be able to max this out at 60 or something, but it's really going to depend on your browser's handling of things we're about to do here. We also have a default background variable here, and we're using just 6-digit RGB hex code to get full control over the color. We can set this to any color we want. Doesn't have to be black, but I'm using black because it's the easiest place to start. We could do white. We could match the color of the actual background that we're using for our page if we wanted to, and then our canvas element would be invisible. It would just blend right into the background, which would be fine if that's what we want, if that's the effect we're going for. But for our illustrative purposes today, we're going for a default background of black so that you can see what exactly is happening. All right. Those are our constants. We will tinker with those only when we need to for testing purposes. All right, now we have a couple of functions that we're declaring here next. Before we get into the real meat and potatoes of what our apps.js page is doing, this right here specifically this line and this might seem a little nonsensical because I didn't explain this stuff last time. But if you remember, over in our main, we do the same thing. And we have a similar thing here. And I suppose we could do a similar thing to encase this, but I haven't, because, I mean, it's not necessary. All of this code gets run. But what we're doing here is we are declaring a nameless function. It's just a function in place. Here we can add some parameters to it. What do we want this function in place to do? We want it to run a function. And we're going to define this function. Now remember, this is for parameters of this unnamed function, which is calling inside of it immediately its own unnamed function with no parameters. Are you confused yet? Good, because you should be. Inside of these brackets here, semicolon at the very end because it's a statement. Inside of these brackets here is where we just put our JavaScript code, you know? Now, this line and this line are entirely unnecessary, but it's a function calling a function to do whatever's in that function immediately when it gets to that line. I don't know who came up with this. I don't know why developers have started doing this. I honestly can't even tell you why I do it other than when I read this, I know that that's the executing part of my module. You remember how when we were doing Python, we had a bunch of declarations, and then at some point we got to that weird statement that was if underscore underscore name underscore underscore equals quote underscore underscore main underscore underscore unquote, and then we'd have some code that would be executed if we just ran that module by itself. This is that part. This is the part that just executes when the script is loaded into browser memory. That's all it's doing. When those modules load, this is the part that actually does something. Is it necessary? No. Do we need this decorative nonsense? Not really. But when somebody reads that and they see that line, they're going to know, oh, you're defining a function here that's going to be called immediately as an unnamed function. So this is basically just like the main function of this module. That's all that is. That's all we're doing there. Don't freak out about it. Necessary? No. God, no. Not even kind of. And args is basically just so that we have a way to feed this main function of these modules some parameters. It's up to us to keep in mind what parameters we're going to be using and what we're going to be using them for. We've already decided the first element in our args list, because that's going to be a list, an array. In JavaScript, we call lists arrays. In our first element of that array, there's going to be a Boolean value, true or false. And that's going to tell us if the sound is muted or not. Alright, that's already been declared for us. We've already got that figured out. As we get fancier, we could add other values here. And that's not going to affect what we've already declared. So, our args still being used in the soundboard and the user control to mute the sound effects. We're still using that first element as a Boolean to control whether or not we're muting our sound. Later, we'll probably use the second element to determine if we want to draw the hit radius so that we can see when things collide or when they should detect that there's been collision. Why would we want to be able to turn that on and off? Because when our user is playing the game, they don't need the circle drawn around all the sprites to know if a sprite got hit or not. For them, it's just going to be proximity. But for our debugging purposes, we're going to want to know exactly where the line is. If something's not close enough to the line, and it's still detecting collision, we're going to need to adjust something. If something has gone over the line and it's not detecting collision, we're going to want to correct something. Because users will pick up on this stuff as they're playing the game. We need to be able to pick up on this stuff in debugging our game. So, this will also be another true-false kind of thing. And if you want to remember what your arguments are, you can just keep a running list. So what's this telling me? The first value in our args is going to control whether or not sound effects are muted. And that's going to be a true or false because that's a Boolean. Bool is the short name for that. Hit radius, that's going to tell me that that next element is telling me whether or not to display for debugging purposes a circle around our sprites to determine if we're within the proper radius for detecting collision. Because that's the thing we're going to do. Or we're going to have to do. Alright, so back to this apps.js. We have frames per second. That's a variable we're going to use later. Default background, that's a variable we're going to use later. These next few function declarations, these three, are kind of important for drawing the display for our game. First thing we have here is function reload canvas. It takes a width and height as well as a name. First thing it does is it finds an element in our document with an ID of root. As you can see, the only element we have in the body of our document is this one div called root. This is our container. This is the container for our canvas element. Notice I have no canvas element inside of here already. There's nothing here. It's an empty root element. Now we assign the root element to the variable root, and we call this method remove child root.childNodes, and we just feed it the first one because there should only ever be one. In the case of the initial like very start of it, there will be nothing. So that will be a null element the first time. But what this is doing is it's creating a list of all of the HTML elements contained within that root element. So you remember here where we have this board, which is part of this soundboard, contains some rows and some cells. Each of these elements is a child node of its container element. And you can control those by calling the list. And this is just an ordered list of, you know, how they would appear in your code if you actually had them or populated them. First one would be the very first one, the second one would be the next one, and the next one, and the next one. Now keep in mind, if I remember right, this only contains the next level of nested elements. So not like the things nested inside of those things. So like if you had a table inside of this div, the table would show up, but not the table row, and certainly not the table headings and cells. But the table would show up, and it would handle the table as a whole thing. If you wanted to access the individual parts of the table, you would call the table, and then call its child nodes. And so on, until you got to the proper level. Since the only element we are expecting root to ever contain is a canvas element, it'll contain nothing at first, but we call it, we assign it, we remove anything that might be there, because we're not just going to call this when we start, or when the page first loads, but we'll call this multiple times. So, first step, clear anything that might be there. If there's nothing there, nothing happens. Now what we're going to do is we're going to create a new canvas element. Same as whatever canvas element might have been there, but with some new dimensions. Remember how we were feeding it a height, a width, and a name? Well, here we create an element of the canvas type, assign it to canv, give it an ID of name, whatever name we fed it, give it a width of whatever width we declared in those parameters, same with height, and then here's some styling just to make sure that it always appears at the level we want it, with the properties that we want it. We want it to be in the top left, no margins, no padding, absolute positioning, z index of 0. This is our baseline thing. Now, when you see where we're using this reload canvas and where we're getting the height and width properties, you'll understand why it takes up the whole page. Except for when we have this 10 by 10 thing going on. But as you can see, it is exactly fitted to the size of the window. No matter what size we make it, it is always fitted to the size of our window. And the way that it does that soon as this file loads, we're going to call that reload canvas and we're going to feed it the window inner width and the window inner height, as well as the name canv, which is, you know, canv. I mean, that's the name we're going to go by with our canvas element. Just makes it easier for referencing purposes. And then also here, oh, nope, not here. Not there. Not there. No. But, okay, so first thing we do, we reload that. But then we add a listener to our window that checks on a resize. Every time we resize the window, what are we going to do? We're going to run this function right here, which is a function we're declaring in place to call this function, which we want to feed the inner width, inner height, and canv, just like we did up here. So, not only when this thing loads, but every time we resize the window now, because there's an event listener that checks for the resizing of the window, it's going to redraw our canvas element. Oh, and after we declare our canvas element, we append it to that root container. Same way we removed it. We're now going to append it to that root container. The clear board is going to take a context element and the canvas element, and we're going to draw in the context with a fill style the default background that we declared earlier, a rectangle that is the height and width of that canvas element, which, as you recall, should be the same size as the window. And we also have this update function, which, as you can see, does the exact same thing as the resize element, or resizing the window. It just calls reload canvas. Same exact function we did before. It gets the value of, or it gets that canvas element and assigns it to the canvas, to a canvas object. It gets the context of that canvas object, because that's how we call all of our drawing functions, which we're going to need. So, this part might not make a whole lot of sense, but just understand this is necessary to be able to draw on your canvas using JavaScript. And it's what you want to do. It's what you want to do. And then we run that clear board that we declared up here, where it just takes the default style and draws a big ol' rectangle, starting at the top left, 0, 0, extending all the way to the full width and height, filling it in with whatever we declared as a default background. Now you see here I have this this comment that says begin drawing here. We've cleared the slate. So every time we're running this update, we're going to clear the slate, and we want to begin drawing the frame, each frame of our animation, of our game, starts here. Now, if you're not familiar with animation, if you're not familiar with how animation works, you've probably been living under a rock, and I apologize. Someone should have informed you. But when the human eye is shown pictures in rapid succession that are similar, not exactly the same, but similar, and only deviate in ever so slight manners, so as to be in sequence, stills of, motion going through time. You can flash those in front of the eye in rapid succession, and to your eye, it will appear as though the picture is moving, even though what you're actually seeing is just a sequence of pictures in which a little bit of a different part of the motion has been captured in a still shot. So the way our game is going to work is we are going to draw each of these frames, these still shots, in sequence and display them for you, but just long enough for you to see them and let your brain process, and then it will draw the next still in the animation sequence. So all of our stuff will move ever so slightly and then be redrawn, shown to you, erased, move ever so slightly, be redrawn, erased, move ever so slightly, redrawn, erased, move ever so slightly. And in this way, we are going to animate our sprites. Now we finally get to the meat and potatoes of what this episode is supposed to be about. Sprites! Oh. Now, as you might notice here, I've got these. I don't really like these being here. I want to take this, and I want to put this back in user controls. Because I don't want the user controls mucking up what's going on in here. Alright, before I get to sprites, though, let's talk about the game loop, okay? Because, sure, we've talked about how there's this event listener for if it resizes the window, but how does it know to just update the frames normally if you're not resizing the window all the time? Well, we have a game loop. We declare a variable, and we set interval. This is just a JavaScript function. It's a predefined function that exists in JavaScript, set interval. The arguments it takes is the function you want to call, which is just going to be our update function, and then the frequency, which in our case is going to be in terms of milliseconds, 1,000 milliseconds to a second. So 1,000 divided by the frames per second. All right, that's where our speed control comes in. All right. So every 1,000 milliseconds divided up by however many frames per second we're asking for. We want to run the update function. And that'll go until we unload this tab. It's going right now. You can't see anything because we don't have it drawing anything after it's clearing the board. But right now, it's clearing the board and redrawing that canvas element 30 times a second. Now there's no shuddering, there's no anything. If you get too complicated with what you have it drawing per frame, you will start to get there. Okay? Like, if you have it doing too much between those 30 seconds that it can't do it all in the time that you're giving it, you'll start to get some flickering. You'll start to see some effects of that. But here's where we start to draw our sprites. But before we can get to drawing sprites, we need to understand sprites. This thing here, I've got the tab here somewhere. Okay. You know what? Probably the better way to show you this is going to be to show you something that I've already made. This is me. I suppose that's gonna work, is it? No. That's not gonna work. Let's try... Whoop. This was a project I was working on for a friend a while back. She's a there isn't a Pages site there, huh? Why isn't there a Pages site? Oh, because I spelt it wrong. That's why. Still isn't there. Why isn't it there? Huh. Well, that's inconvenient. Okay. Anyway. Let's look at, since it's not going to be convenient, we can still look at the code. All right. This first part, this is just a tarot deck object. Layout cards. The cards, I just, I wrote out the entire deck of 74 tarot cards. And then I gave it some functions for shuffling, for dealing. When it initializes, it goes through that entire list of cards, and it goes through the images for those cards, and loads a new image, declares the source of the image from the available sources there. Here you can see we're using that same setup for whoop, minimized the wrong window. There we go. We're using the same setup for window canvas reloading when the window resizes. But we're also initializing the tarot deck. Tarot deck, where's the initializing? What does that do? Goes through all of them and assigns the various images. Alright, and this image object, this already exists in JavaScript. Now, as for what the rest of these functions do, these are just handling the placement of cards and stuff, you know, where you click and whatnot. I'd love to show it to you, but for some reason the page doesn't load anymore. I don't know why. It's kind of annoying. Did I link to it on here by any chance? No, but I do a similar sort of thing here. This part is a canvas element, and we have a clock being drawn here. We have these objects here. Let's see, what is it, Wednesday? Wednesday. Wednesday. April 13th. This is a thing I made for my son. During his homeschool time, One of his favorite things to do at the start of every day was to help set up the calendar. And so I made this thing for him where we can draw on it. You know. This is all done in JavaScript, by the way. You can draw on the clock. The erasing and the drawing happens a little bit strangely. Because what we're doing here is actually drawing really fat pixels. And then to erase them, we're using mouse detection to determine, where you are, and all the pixels that we've drawn previously, their positions are being stored in an array, and we go through the array and we determine if any of those pixels are close enough to the mouse, they disappear. So that's how the erasing works there. It's not an exactly perfect sort of drawing board. It can get bogged down if we draw too much on it, but it does work as sort of a little dry erase board kind of thing. It's a chalkboard. But we used this during the first year of the pandemic, when right after his school closed. He finished out that year doing online schooling, but then we took a homeschool year because it was either that or I enroll him in public school, which I didn't want to do because we were going to be moving. We were actually just slowed down from moving because of the whole pandemic and everything. So things didn't exactly go the way we were hoping they would go. But anyway, this is the kind of stuff you can do on a canvas element. These things are all just being drawn. This is a Phases of the Moon thing, little indicator. I don't know if that still works properly or not, but what it's supposed to do is it's supposed to check computer time, figure out the date, and from the date determine what phase of the moon we ought to be in. If I remember right, it's accurate up to a certain year before it needs adjusting. I can't remember when that year is, though. And then this whole Wednesday, April 13th drag and drop stuff. These are, if I remember right, div elements. But what I'm doing with these is checking where I'm clicking. Am I clicking inside the box? And then if I am, as long as I'm holding down the mouse button, I can drag these wherever. So like I could do little labels and do things like no school because it's Sunday, obviously. Math. Spelling. Art. I could do a thing like that. Very simple. This table here is really just that. It's a table. But using math, it calculates out how many spaces to ignore before the first line. And you'll see it actually matches the clock. Getting that to work was kind of a pain in the butt. But, what's really cool is you can change what month you're looking at. And as you can see, it does match. What we're doing there is we're just doing simple math to make it work. You know, that's stuff you can do. It does determine what month we're in, whether or not it's a month with 30 days, 31 days, 28 days, 29 days. A lot of if statements went into that. Now, that's all well and good. But I want to be able to show no, that one's not set up. Matchstick Arena? Do I have that on here? Oh, I don't. Ugh, I really need to update this. So annoying. Because I do have a couple of these little apps that use this this setup of drawing a canvas, and then we draw some pictures to that canvas. And it's just way easier if I can show you that code, but since I can't, since it's not going to let me, going to have to do this the hard way. I was hoping to avoid the hard way. Oh well. We never get to avoid the hard way. But a really good resource for learning how to work with sprites is actually W3 Schools. I know, right? It is kind of a shocker to some people. But they do have some documentation for the canvas element there. They tell you how to use some pre-existing libraries. How you can write to, or how you can draw on the canvas. See, here's where we're using that, remember how we have to get the context of our canvas? Here it shows you how you use that. And if we go over to CSS image sprites, it's going to give us our first example on how we use sprites. All right, a sprite is a single file made up of multiple images. Like this right here, this house and 2 arrows, that's a single image. That's a single file. It's all contained in image_navsprites.gif. Using CSS, you can narrow down what part of the image you want to show. Pretty simple. There we go. Get rid of that line. Oop. I suppose we need the pixels, huh? But as you can see, just by messing with the numbers here, you can change the placement. So you can change which part of the picture we're being shown. That's going to be important. Okay? Because just like with that tarot deck object for that one example I was showing you, we can assign an image file or multiple image files to the objects in our game. So when we get to making our main character avatar, our playable character, we'll have a sprite file of all of his action cells. So there'll be several for walking in each direction. And what we're going to do is something akin to this. And we're going to save these values in a list. Each element of the list defines one cell of the action. As we need the action to be carried out, we will progress through the elements in that list. So, the first element defines the parameters of the first cell. The second cell, third cell, until we get to the end of the action. So when we trigger the action, what we're going to do is for each frame of our animation, every time we run the update, every time we run this update function, it'll progress one cell of the animation. So, if you do a search for sprite sheets, you will see that there are all kinds of sprite sheets, and there's all kinds of tutorials on how to do sprite sheets and how to work with them. I unfortunately don't have any for today's discussion. And we're actually getting pretty close to the end of our time. But like some of these, you can see they get huge. Absolutely huge. Each of these little rows here is defining a single action. But they are all individual moments in time progressing through that action. And what we would do is we would take this sheet, and for each of those cells, we would want to program in to our into our code somewhere these coordinates for each of these cells. And you might be thinking, oh my god, that just seems insane. And you're not wrong. There are shortcuts, okay? You've seen us do loops where we increment some value by so much. Well, imagine if you could loop through each of the rows in one of these sheets. That would cut down what you need to work on. And from there, if all of these cells are the exact same width, you could even increment moving over each one as you're assigning these to their appropriate placeholders within your object. And that's exactly what we plan to do. However, first we need a sprite sheet that we can work with. So we need to make some decisions. We need to decide, are we going to make one? Are we going to steal one? Are we going to get super complicated with how many cells we want? Because the more cells you have, the smoother the action. The higher the frame rate, the smoother the action. And in a way, you need to think about your frame rate and the number of cells you have. Alright? If your frame rate is low and the number of cells you have is high, the action is going to feel sluggish. The action is going to appear sluggish because it's going to want to render each one of those frames before the action is completed. Conversely, if you have very few frames or a very high frame rate, it's going to get through that action super fast. And it may just not look good at all. Okay? Your character may not even seem to render anything other than a resting state because it just moves through all of the frames of an action before your user can even comprehend that an action has been performed. So, you do want to think about that a little bit. You want to make sure that you're considering, when you're doing your animation, how long should a motion take to complete? What is the frame rate we're going to be working with? And that'll tell you how many frames you have to complete that action. And then you'll want to think about where your character will be at each of those cells. I know that seems really complicated. But for simple games like what we're going to be doing, it's really not that complicated. Alright, and I actually found a really good article here that explains the method we're going to be doing here. So I'm going to throw this on the screen for you all. Prashant Ram of Daily JavaScript, or, for Daily JavaScript, wrote this wonderful article. You can find this on medium.com if you do a search. Using this very basic character sprite cell strip. And he goes into talking about what is the sprite. What is a sprite sheet? Gives you an idea on how to do this stuff with the HTML and CSS. But if you keep going, he's got here an animate script. And here he's using something a little different. Because he's using this that's a little hard to see. Let me make that bigger. Anyway. So, in his animation, he defines a start position for the image slicer. He's going by 100 milliseconds for updating his interval. Because here is where he's setting that interval. That portion for us is just this part here. Where is that? Am I looking on the right thing? Probably not. No, here it is. Instead of using interval, we're just doing some basic math with some frame rates. Okay? Because we're just going to set the game loop to the frame rate. No reason to go any more than that. And then here he's got the code for changing the position. And what he's doing here is he's taking the element from his HTML, which is just this right here, and feeding the background position. They're using background position. We're probably not going to use background position because we're going to be drawing the image to a canvas element rather than applying it to a background. So that's going to be a bit different for us. But it's a similar idea because for each time his loop runs, what he's doing is he's changing the position of the image slicer, which is this right here, where it's positioning the background. And then here's where it does the math to determine how many times over it'll allow it to go before it has to loop back, because keep in mind, limited space in a sprite file, it just doesn't go on forever and ever and ever. At some point, you're going to hit one of the ends of your sprite sheet. You want it to be able to kick back over. Well, we're going to handle this in a slightly different manner, okay? We're going to do this a little different, because what he's doing is he's handling all of this as just showing you each loop, the background of one of his HTML elements is going to be a portion of this image. What we're going to do is something similar, but what I think is a little more elegant. We're going to have an object. We're going to create a sprite object. We're going to have an array of motion, essentially. And within this array will be other lists, other arrays. And each element in each of those lists will be a single cell that composes one part of an action. And in sequence, they'll complete the action. And instead of incrementing by pixels each time, we're going to increment by elements of the array, because we will have already defined the pixels in advance. And the images will already be set up, ready to go. And we're going to page through them that way instead of this way where we're sliding an image around within the element. We're basically going to take a part of an image, make that the thing, and instead of changing by pixels, we're just going to change by elements in an array. It'll be simpler in action, I promise you. However, we are going to save all that for next time, because I still have to get a sprite sheet put together, which means I have to make some decisions as to what we're doing for our game, because we've talked about how we're gonna make a game, we're gonna do something. But now we've come to the point where we need some assets. I'm gonna have to make a sprite sheet. And I want to try to get it together before next time, so that we have something we can work with. And our sprite sheet needs to have every cell of animation we need for whatever it is our character is going to do. I'm not an artist. I am not an artist. So, I'm going to warn you ahead of time. It's probably going to be some stick figures. It's probably going to look silly. Might look incredibly stupid. I also have to remember how to do transparencies in Gimp. We might go so far as to actually spend next session showing you how to use Gimp to make transparencies. That's a thing. It's a skill you're gonna want to learn. And the reason you're gonna want to learn it is because the background of all of these sprite sheets that you find, a lot of them, what you'll see, you see this weird little checker pattern background. Well, that checker pattern is indicating that's supposed to be that's supposed to be transparency. Shows up as a checker pattern to indicate to us, because we cannot see that it is transparent with our eyes. That's kind of the point. But we still need to be able to indicate what we're looking at there is a transparency. Using Gimp, it's actually really easy to do transparent images. And I use Gimp for all of my needs for this kind of work. I use Paint for the really simple stuff, when I just need some bit of clip art and it doesn't need to have a transparency. But if I need to go so fancy as to actually have transparency, I use Gimp. I'll show you that next time, because that's a whole beast in and of itself, and something we're also going to want to know when we get back into Python. Because like I said, we're also going to learn how to make Python games. This whole jog into JavaScript, what we're doing here is just a diversion from that Python tutorial. We needed a break from it. We wanted to do something else. So here we are, doing something else. But we've now come to a point where we're going to start talking about skills we can use in both. So, we're going to do that. We may also go so far as to load in the coordinates of our sprite cells using that little Python program that we wrote, because some of that will probably be faster and easier to do than if we just try and do the math by, remembering all that stuff. We could probably do it faster and easier and then just load it in as an Ajax asset to tell us where all those cells are. So that's what's coming. We'll get into building our sprites and stuff next week. This was just a little primer into what it is you can expect and how exactly it is we're going to do that animation, as well as how we handle full window apps, being able to draw them and not have awkward scroll bars where we don't need them. Because this looks clean. Like, when we have this gone, like, this is all something we can draw in. And because we know the height and the width, we also know the center. We just have to divide the height and width by 2. We know the exact center, which is probably where we're going to place our main character. Our main character will probably sit right smack dab in the middle of our screen, and as he runs to the left, the background behind him will move to the right. As he runs to the right, the background behind him will move to the left to give us the illusion of motion. He'll probably stay in place, but all of the stuff around him will move in relation to him. And, yeah, it'll be kind of an interesting little effect. You'll see how that all works. But doing that, we can do the placement of our main sprite just dead center. We'll also have like a player heads up display, but displaying the elements of that is going to require a little bit of finesse, because we want to be able to make this look good on, again, desktop or mobile device. So we're probably going to want to limit the size of our elements so that they're not taking up too much space, because on a narrow, smaller screen, it's going to look funky. On a wider screen, they're going to get lost. They're going to be super, super tiny. So we got to think about those elements. I may also do some kind of interesting ideas for our game, because there's some stuff that I've been noodling around in my brain. There was this Python game that I saw that does like a procedurally generated maze, like a real basic maze, and it does it in ASCII characters, and then you navigate the maze to find the treasure. It really wouldn't take much to translate this over into JavaScript. Instead of ASCII characters, we would instead use sprites to render different cells, instead of ASCII characters rendering the different cells. So I might try something like that, and we could probably make a pretty good game out of that. But anyway, we'll get into that next time. I don't know if that'll be this coming week or the next week. I might take a week off. Just from the code thing. Probably not from gaming and stuff. Tomorrow, we're playing Metroid Prime again. So, if you tune in for the video games, you're going to want to tune in for Metroid Prime tomorrow. We've been making some really rapid progress in that. We've only died like twice, I think, the whole time. And we've already cleared the plant boss, if I remember right. I can't remember how much further we got than that, but I know we cleared the plant boss. Yeah, we're getting through that real quick. Friday, we're still playing Legend of Zelda Breath of the Wild. We've got a lot more glitches and exploits to explore. This week, we're going to look at menu overloading and item duplication, because we've done everything else in the game. Why not have some fun with just being able to create as many Korok leaves as we want, as many Hylian shields as we want, as many, whatever. it'll be a fun time. Let's see. Next week Tuesday or Monday, next week Monday, Metroid Fusion. We're back to playing that. We've made a little bit of progress, not very much progress in our playthrough on that one, but it does seem to be going okay. Seems to be going pretty well. Let's see. What else do we have? Tuesday, Murph Strange presents a Bloody Strange podcast, assuming everybody who's involved can be can be counted on to make it. We're going to be having a very special Zeph takeover episode. She's been working on this idea for an episode of her choosing, and honestly, I'm kind of excited to see what she's come up with. I helped a little bit with the research, but for the most part, it's been entirely her on this this upcoming episode, so hopefully she's up to it. We skipped it yesterday because Gilbert Gottfried passed away, and that was kind of tragic. We felt that, and neither one of us were really up to an episode yesterday, so we decided to just take the day off. But hopefully next this coming Tuesday, we can get that episode recorded. And then Wednesday we'll be back to this, where we are actually going to code with some sprites, because I'm going to show you how to make some sprites. Y'all are going to have to forgive my really awful artwork, because I suck at art. I do. I'm not great at it. And you're going to see that. It's going to be awful, but you're just going to have to deal with it, because I'm the one teaching you how to do this stuff. If you wanted to learn from somebody with talent, there's plenty of other people out there also teaching this stuff. Feel free to go learn from them. I really don't mind. But, if you're enjoying this channel, keep coming back. We're still doing stuff. Probably after we get our little JavaScript game here made, we will probably head back into Python, pick up where we left off. We're going to hammer down on doing network communication. We're going to hammer down on how to work with third-party libraries, setting up virtual environments, that kind of stuff. So there's a future there for all of you Python fans. We're going to be getting back to that eventually here. But as you'll see in the next coming episodes of Murph Codes Anything, we're still using the Python project that we wrote last time. It may not be as pretty as we wanted it to be, but it's still functional, and we can still use it for the things we wanted to use it for. So we're going to use it. And you'll get to see how that's going to help us out here with some of these things that we're going to be making. So that'll be fun. Yeah, that's all the news I've got to report for now. I thank you all very much for putting up with my low energy today. I wasn't expecting that I would have a sudden just complete drain of energy before hitting that go live button, but man, I tell you, the half hour leading up to it, I could just feel it. I'm gonna need a nap. Hope I'm not coming down with a cold. But, considering my kid just had one and it's been ripping through his school, I wouldn't be surprised. So, hopefully it won't interfere with the other stuff we'll be doing. But we now have a blank canvas to work with. Next time, I'm going to show you how to throw stuff at it so that we can really really make this thing pop. Get this thing doing something cool. Till then, y'all have yourselves a wonderful day.